Hello, welcome to our chemistry class. And in chemistry today, we shall be looking at the topic redox equation. This is a development from the redox reaction and calculation of oxidation number. Now, when we talk about redox equation, they are generally written down in ionic form. So we have one anion, a cation, and then we have some electrons over there. We have two methods of balancing redox equation. We could use the half cell reaction method, which is also known as the ion electron method, and we could also have the oxidation number method. We shall look at the two methods. The redox equation could be a simple ionic equation, or it could be a complex ionic equation. We shall study and solve questions under this. Now, when we talk about the complex ionic equation, we will have in an acidic medium and in an alkaline medium. So let's move on to delving into balancing this equation. Alright, so let's look at simple ionic equation. Balancing it by the half cell reaction method. Now there are steps by which we can use to balance this simple equation. We will follow these steps. Now there is a first step which says that we should write down the oxidation number of each element or ion present. Step 2 says we should divide the equation into two half cell equations. That is the oxidation half cell equation and the reduction half cell equation. 3, we have to balance each half cell equation. Thus, we have to balance the atoms first, and secondly, we balance the charges. The fourth step is to multiply each half cell by using the coefficient of electrons to balance electron gain or loss. And the fifth step is to add the two half cell equations in order to get the net equation. And we should take note that the electrons will be cancelled out. Now let's proceed to balance this. The first step is to write the oxidation number of each of the elements or ions. This oxidation number of sodium here is 0. The oxidation number of this hydrogen cation is +1. Here we have +1 as its oxidation number, and we have 0 as its oxidation number. The next step is to write out the half cell reactions. So we'll divide it into oxidation and reduction. For the oxidation, now we have sodium becoming Na+, and then we have H+ becoming H2. From here, oxygen is 0, and then it became +1, meaning that it has undergone oxidation. So here we have an oxidation reaction, and hydrogen, which was +1 here, has turned to 0. Hence, this is a reduction reaction. Then step 3, we have to balance the atoms. To balance the atoms, we have one atom of sodium here, and we have one atom of sodium here. So this is balanced. But hydrogen here is not balanced because we have two atoms of hydrogen here, and we have just one atom here. And so to balance it, we place 2. Hence, that has been balanced. And next, we balance the electron. And how do we balance the electron? Now let us place it side by side. We have Na, then Na+, and then 2H+, producing H2. To balance the electron, here we have 0. We have 0 as the oxidation number here, and then we have +1 here. And so that means that sodium atom has lost electron. When it loses electron, it becomes Na+. And over here, it means that hydrogen ion has gained 2 electrons. When it gains 2 electrons, it becomes H2. Now we have balanced the electrons. And next, we have to multiply each half cell by using the coefficient of the electrons. If you take a look at this, we have 2 electrons here, but here we have just 1 electron. So to balance these two, we need to multiply this equation 1. So we have this as equation 1, and we have this as equation 2. So we need to multiply this equation 1 by 2. this equation 2 needs not to be multiplied by anything but 1. And so 2 multiplied by this, we have 2Na minus 2E minus to give 2Na plus. And then we have 2H plus 2 electron to produce hydrogen. So don't let's forget that this is the oxidation and here is the reduction. With that said, we would cancel out these electrons because we have minus 2 plus 2, which is 0. We will combine the two reaction. So we have 2Na plus 2H plus to produce 2Na plus H2. Here we have solid, we have aqueous, here we have aqueous, and we have a gas. Hence, this is the net equation. Alright, so next we want to balance the equation by half-cell reaction methods. We follow our procedure step by step. First, we write the oxidation number of each of the elements and the ions. Here, zinc has 0, plus 1, plus 2, and 0 as their oxidation number. Next, we'll write the half-cell equation for both the oxidation and the reduction. First, we have zinc becoming Zn2 plus, and then we have silver plus becoming silver. Alright, from here, zinc has increased from 0 to 2 plus, meaning that it has lost 2 electrons. And when you lose electron, that is called oxidation reaction. So we have oxidation. And here, silver has gained electron. It gained 1 electron. So gaining an electron is a reduction reaction. So we have reduction over here. Next is that we balance the atoms. When we take a good look at this, we have 1 atom of zinc here and we have 1 atom of zinc here. That is balanced. And then we have 1 atom of silver here and we have 1 atom of silver over here. So that means that the atoms are balanced. Then, still under step 3, we need to balance the electrons. To balance the electron, we write them side by side. So we have zinc becoming Zn2 plus, and then Ag plus becoming silver. Now we said that zinc over here lost 2 electrons. So we have minus 2 electrons to become Zn2 plus. And then we have silver ion has gained an electron to become a silver atom. Alright, so this, okay, now, so from here, we will have that we have 2 electrons for zinc here, and we have just 1 electron for silver here. So what we'll do is that we'll multiply this. Now this is our equation 1, and this is equation 2. We'll multiply equation 2 by 2, and we'll multiply equation 1 by just 1 because the 2 electrons are there, and that would give Zn minus 2 electron, and then zinc cation, and then we have 2 Ag plus, that's 2 silver ion plus electron. Okay, we have 2 here, then we have 2 Ag. Now don't forget that this is still our oxidation reaction, and here we have our reduction reaction. Next is that we will combine the 2 equations in order to have our net equation. To combine it, we have, now the electrons are going to cancel out because we have minus 2 electrons and we have plus 2 over here, so they cancel out. We'll be left with Zn, that is zinc atom, plus 2 moles of silver ion to give 1 mole of zinc ion plus 2 moles of silver atom. Hence, this is the net equation. Next, we want to balance this reaction by half cell reaction method. First, we will have the oxidation number written. The oxidation number of this cation is +2. For bromine, we have 0. For ion here, that's ion 3, we have +3. And for bromine, we have -1. So there is an alteration in the oxidation number. Next is to write the half cell reaction for both oxidation and reduction reaction. For ion, we have Fe2+ becoming Fe3+. And then for bromine, we have Br2 becoming Br-. There's an increase from 2+ to 3+. And this means that ion has lost electron. And when it loses electron, that means we have an oxidation reaction here. So here we have oxidation. For bromine, which was originally 0, 0 has become -1. It means that it had gained electron, and that is a reduction reaction. Next, we'll balance the atoms. And to balance the atoms, we write them side by side. Here we have Fe2+ becoming Fe3+, and then we have Br2 becoming Br-. We have 2+ as the oxidation number here, and it has increased to 3+ here. So we are saying that this has lost 1 electron. First thing we need to do is to balance the atoms. We have 2 atoms of bromine here, and we have 1 atom here, and so we'll put 2 here. For ion, we have 1 atom of ion here, and we have 1 atom of ion here, so the ion is balanced. Next, we balance the electrons. We have ion here. Ion has lost 1 electron, so we have -E. For bromine here, it has gained 2 electrons. How? Because we have 2 atoms of bromine here, and we also have 2 atoms here. Hence, each atom must have gained an electron. So we have +2E-. Next, we need to balance the electron on each side. And to balance the electron on each side, let's not forget that this is the oxidation reaction, and here is the reduction. We have 2 electrons present here, and we need to balance the electron here to be 2 also. So what we need to do is to multiply this first equation by 2 and multiply this by 1. It doesn't change. And so we'll have 2Fe2+ minus 2 electrons to produce 2Fe3+. And for the equation 2, we have Br bromine plus 2 electron to produce 2Br-. So this is the first equation, and here is the second equation. And next, we will combine the 2 equations. Before we combine the 2 equations, this electron will cancel this electron because we have 2 electron here, minus 2 plus 2, that is 0. And so we'll have 2 ion, that's 2 ion, 2 ion, plus bromine gas to produce 2 moles of ion 3 plus 2 moles of bromine anion. We have here as aqueous, we have gas, we have aqueous, we have aqueous over here. So here's the net reaction. Alright, next we want to balance a complex ionic equation such as this by the ion electron method. To balance using this method, the medium could either be an acidic medium or an alkaline medium. For instance, this is an acidic medium. When we look at it, we have just 1 oxygen over here, and then for us to balance this, we have to balance it by introducing water molecule on the other side and then hydrogen ion on this other side. And so because of the hydrogen ion that is introduced, it is the introduction of an acid. Now that means there will be an acid that will be introduced on this side in order to balance it up. We have steps that needs to be considered. So these are the steps quickly. We have to write down the oxidation number of each of the elements or ions present. Then we have to divide the equation into two half-cell equations. That is the oxidation half-cell and the reduction half-cell. And then we have to balance each half-cell equation by number one, to the reduction half-cell. To the reduction half-cell equation, we add hydrogen ion and water to reactants and products respectively. Then we balance the atoms present using appropriate coefficient number, and finally we balance the charges using appropriate number of electrons. And then to the oxidation half-cell equation, we balance the atoms present using appropriate coefficient numbers, and then balance the charges using the appropriate number of electrons. And then the fourth step is to multiply each half cell by using the coefficient of electrons to balance the electron gain or loss. And lastly, we add the two half cell equation to get a net equation. And don't forget that the electrons will cancel out. Now let's proceed into balancing this equation. First, we need to write out the oxidation number of each of the elements. Here, the manganese, the oxidation number of manganese here is +7. For oxygen here, it is -2. Now, this minus is for the entire radical, so we are not taking this minus. 14. Now, for you to understand how we got this +7, we need to view our video on redox reaction and oxidation number. Then 14, the oxidation number here is +2. For manganese, we have +2. 14, we have +4. Next, we write the half cell equation for the oxidation and the reduction reactions. We have MnO4- becoming Mn2+, and then we have Sn2+ becoming Sn4+. Now from here, our emphasis is on the manganese. Manganese here is +7 and it has become +2, meaning that it has gained electrons. It gained electron, so that's why it became +2 all the way from +7. And so when it gains electron, that is reduction. And so we have reduction over here. And then for tin has increased from 2+ to 4+. And with that, it means that tin has lost 2 electrons. So we have that as oxidation, because oxidation is loss of electron. The next step is to balance each half cell. We are balancing the atoms as well as the charges. Now let us balance the reduction reaction first. For the reduction reaction, we have MnO4- becoming Mn2+. Now for us to balance it, it's going to require us adding H+ ion and water to the reactant and product respectively. Here we have 4 oxygen atoms. That's going to determine the moles of water we'll add here. We will add 4 moles of water. We're adding 4 moles of water because we have 4 oxygen here and we have 4 oxygen here, meaning that the oxygen is balanced. Now after adding that, we notice that we have hydrogen that has been introduced to the product side. And to balance it on the reactant side, this is 2 times 4, that's 8. And so we had +8 hydrogen ion to the reactant side. Next, to balance it completely, when we take a look at the sum of the ions on this reactant side and the product side, we will realize that on this reactant side, this -1 is for this entire radical. So we have -1 and then +8 on this side. And on this side, we have just +2, meaning that we have +7 and we have +2. In order to have both of them equal, we have +7 over here and we have +2 over here. For us to balance it out, what we could do is to add some electrons over here. So what we need to do is to add 5 electrons, because when we add 5 electrons here, the electron which is negative, will cancel out 5 from here. So when you add 5 electrons, that is minus. So minus 5, and that is plus 2. So we add 5 electrons to this side. With that, we have equal number of ions on the two sides. That is, we have plus 2 on this side, and then we have plus 2 on this side. And then this is for the first equation, and that is the reduction. For the oxidation side, we have SN2 plus and SN4 plus. From here, tin has lost 2 electrons. When it loses 2 electrons, it becomes 4 plus. Here is the oxidation, and here we have our reduction. Next, we need to balance the electrons. We have 2 electrons here, and we have 5 electrons here. And so this can be balanced by multiplying equation 1 by 2 and equation 2 by 5. Why? Because we use the 5 for electron here to multiply this equation 2, and we use this 2 electron for equation 2 to multiply equation 1. And that will give 2MnO4 minus plus 16H plus 10E minus, and then we have 2Mn2 plus 2 times 4, that's 8H2O. For the oxidation, we have 5SN2 plus minus 10E minus to produce 5SN4 plus. After they are balanced, the electrons will cancel out because plus 10 minus 10 will have 0. And finally, we'll write our net equation. The net equation for this reaction will be 2MnO4 minus 16H plus 5SN2 plus, and then we have 2Mn2 plus 8H2O plus 5SN4 plus. Here we have aqueous, we have aqueous, we have aqueous, we have aqueous, we have liquid, and we have aqueous. So this is our net reaction. Next, we want to balance this equation occurring in an acidic medium using the ion-electron method. So move step by step. First is to write the oxidation number of each of the elements. Here, chromine has an oxidation number of plus 6, oxygen has minus 2, lead has plus 2, chromium has plus 3, this is also chromium, and then this is lead, which is plus 4. Those are the oxidation number. Next, we'll write the half cell equation for both the reduction and oxidation reaction. Now we have, for chromium, we have Cr2O7 2 minus becoming Cr3 plus, and then we have for lead Pb2 plus becoming Pb4 plus. Chromium over here, chromium is plus 6, which has become plus 3. So meaning that there is a reduction in the oxidation number. It means that it has gained electrons, and when it gains electron, that is reduction. So it has undergone reduction reaction. Next, lead over here has lost 2 electrons, and when it loses electron, it has undergone an oxidation reaction. Next, we will need to balance the atoms and the electrons. First and foremost, we have 2 chromium atoms here, and we have just 1 chromium atom here. And so what we need to do is to balance it up, we place 2 over here. Next, we will have the half cell side by side. Alright, so let us balance for the reduction first. We have Cr2 O7 2 minus, which has become 2Cr3 plus. We have 7 atoms of oxygen here, and to balance on this side, since it is an acidic medium, we'll add 7 moles of water, meaning that we now have 7 atoms of oxygen here and we have 7 atoms here. Hydrogen has been introduced here, which we have 14 atoms of hydrogen introduced, and that will be balanced by adding 14 atoms of hydrogen ion on the reactant side. Next, we need to balance the electrons. To balance that, when we look at this radical, it has 2 minus, and then we have 14 plus here. So we have minus 2 plus 14. We have a net of plus 12 on this side. While on the product side, we have 3 plus multiplied by 2. So we have 6 plus over there. Hence, for us to have an equal number of ion on both sides, what we need to do is to introduce some electron. And that means that we'll introduce 6 electron. When we introduce 6 electron, since electron is negative, the negative will be 12 minus the electron, and that will give plus 6, and then we have plus 6. So we add 2, we have 6 electron on the reactant side. With that carried out, the reduction reaction has been balanced there. Then we go to the oxidation side. We have lead, which has become Pb4 plus, meaning that it has lost 2 electrons. So we have minus 2 electrons lost. Now with that done, this is the oxidation side. Next, we need to balance the electrons, since we have 2 electrons here and we have 6 electrons here. And so to balance the electron on the reduction and the oxidation equation or reaction, we'll multiply the reduction by 2 and multiply the oxidation by 6. And so we have 2 Cr2O7 2 minus plus 2 times 14, we have 28 H plus 2 times 6, we have 12 E minus, and then we have 2 times 2, we have 4 Cr3 plus 2 times 7, we have 14 H2O. For the oxidation reaction, we have 6 times this, that will be 6 lead 2 plus minus 12 E minus to produce 6 Pb4 plus. The electrons will cancel out because we have plus 12 minus 12, so they cancel out. Next, we'll combine our equation. But if you look at this equation, we have 2, 28, 4, 14, 6, 6. And we have, that means we have a common factor, a common factor there, which is 2. So we could divide all through by 2. But before we do that, let's write the entire equation. Now the equation is 2 Cr2O7 2 plus 28 H plus 6 Pb2 plus, that's this and this, and on the product side we have 4 Cr3 plus 14 H2O plus 6 Pb4 plus. This is the balanced reaction. But since we said there's a common factor there, we can divide each of the coefficients by 2. And when we divide by 2, we'll end up having Cr2O7 2 plus 14 H plus 6 divided by 2, that's 3 Pb2 plus, then to give 2 Cr3 plus 7 H2O plus 3 Pb4 plus. Here we have an aqueous, aqueous, they are all aqueous, okay, except the water. And so we have a balanced equation. Alright, next we want to balance this redox reaction in an acidic medium using the ion electron method. When we take a close look at this reaction, there is the presence of oxygen on both reactant and the product side. And so for us to work this out, we'll need to add water and hydrogen ion to both sides of this reaction at a particular point in time. So let's proceed. First, we need to write the oxidation number of each of the elements. Over here, the oxidation number of manganese is +7, oxygen is -2, sulfur is +4. Here we have SO2. Alright, so oxygen here is -2, manganese is +2, sulfur over here is +6, and oxygen here is -2. We need to write the half cell equation for the reduction and the oxidation reaction. To do that, we have MnO4- becoming Mn2+, and then we have SO2 becoming SO4- From what we have here, manganese, which was +7, has reduced to +2. And for it to have reduced, it means that it must have gained electrons. Specifically, it has gained 5 electrons. And so we have this as reduction. So because it has gained, it is called a reduction reaction. And over here, sulfur, which was originally +4, has increased to +6, meaning that it has lost electron. And when it loses electron, it means that it is an oxidation reaction. So this is an oxidation reaction. Next, we want to balance the atoms and the electrons. We balance the atoms by introducing water and also hydrogen ion. So first we have MnO4-, which has become Mn2+. 4 atoms of oxygen here will lead to the introduction of 4 molecules of water. So 4 oxygen and 4 oxygen. The oxygen there is balanced. Next, before we have 2 times 4, 8 atoms of hydrogen here, and that would lead us to adding 8 hydrogen ion to the reactant side. Next, we need to balance the electrons. To balance the electron on this side, we have -1 on this radical, and then we have +8 over here, which gives us +7. And here we have +5 as the entire ion that we have. To have equal number of ions, what we could do is to add 5 electrons on the reactant side. And so when we add 5 electrons, that means it has gained 5 electrons. And 5 electron is a negative. So we have +7 minus 5. You know, although we said plus, but it is a minus, it's a negative. So +5 minus 5, that's +2. So +2 on this side and +2 on the other side. That is balanced. Next, we look at the equation 2. We have SO2 on the reactant side, and we have SO4- on the product side. We have 2 atoms of oxygen here, and we have 4 atoms of oxygen here, meaning we have more oxygen here than here. Hence, we need to introduce water here. We have 2 hydrogen more than this place, so we have 2 H2O over here. Now we have 2 of oxygen, we have 2 oxygen, making 4, and then we have 4 over here. The introduction of 4 atoms of 2 here has brought in 4 atoms of hydrogen. So we have 2 times 2, that's 4. So we have 4 hydrogen here. To balance it out, we had 4H+ on the product side. Next, we need to balance the electrons. To balance the electron on this equation 2, we need to look closely at it. We don't have any ion over here. We have ion here and here. So for here we have 2 minus and 4 plus. And this gives us a resultant of minus 2 plus 4, and that is plus 2 electrons. So we have plus 2 here. To balance it up, what we could do is to add 2 electrons here. Now, we will not want to add it here. We would like to add it to the reactant side so that we will have the electrons on the reactant side of both of them. And so we'll take it off and we'll have it as minus 2 electrons. So instead of having plus 2 electrons here, we have minus 2 electrons here. Now this has balanced the equation. Next, we need to balance the electron on this equation 1 and this equation 2. And that can be done by multiplying the equation 1 by 2 and multiplying equation 2 by 5. When we do that, we would end up having 2MnO4 minus plus 16H plus 10E minus, and then 2Mn2 plus 2 times 4, that's 8H2O. Next, we have 5 here, so 5 multiplies it, that's 5SO2 plus 5 times 2, that's 10H2O, minus 5 times 2, that's 10E minus, and then 5 multiplies it, that's 5SO4 2 minus, plus 5 times 4, that's 20H plus. Next, the electron here cancels out the electron here. So this electron is gone. Now the next thing is to bring the two equations together. Let's bring this water molecule to the reactant side and the hydrogen ion to this other side, because they will end up cancelling out. Here's what I mean. So what you will have will be 2MnO4 minus, then let's take this, plus 5SO2, then we have plus 10H2O. This 16H plus, we want to move it there. Then we'll bring this H2O over here. And so we have minus 8H2O. And on the product side, we have 2Mn2 plus 5SO4 2 plus, and then plus 20H plus. And next, we'll bring this 16H plus over to the other side. That will be minus 16H plus. Yes, very long equation. Now, we have 10 molecules of water here, and here we have 8 molecules. So 10 minus 8, we are left with 2. The net reaction will be 2MnO4 minus plus 5SO2 plus 10 minus 8, because this is water and water, so they cancel. They will subtract. So we have plus 2H2O, and then over here we have 2Mn2 plus 5SO4 2 plus, and then we have 20H plus minus 16H plus. They are like them. So 20 minus 16, that leaves us with plus 4H plus. Hence the net equation. We want to balance this reaction in an alkaline medium using the ion electron method. And there are certain steps which needs to be followed. And so we'll quickly go through the steps. The step 1 says we should write the oxidation number of each of the elements or ion present in the medium. 2, we are to divide the equation into 2 half-cell equations. 3, we are to balance each half-cell equation. Thus, number 1, to the oxidation half-cell equation, add OH minus H2O, that is to the reactant side, and then you add H2O to the product side. Then you balance the atoms present using appropriate coefficient number, and finally balance the charges using appropriate number of electrons. And number 2, to the reduction half cell reaction, add water to the reactant side and OH minus and water to the product side. Then balance the atoms present using appropriate coefficient number, and then balance the charges using appropriate number of electrons. And 3, then balance the charges using appropriate number of electrons. Now step 4, multiply each half cell by using the coefficient of electrons to balance electron gain or loss. And the 5th step is to add the two half cell equations in order to get the net equation. And don't forget that the electrons cancel out. So let's solve this question in an alkaline medium. Now we'll move on to the first step. We have to write the oxidation number of each of the elements. Here we have iodine having +5 as its oxidation number. Oxygen has -2. Sulfur over here has +4, and oxygen here has -2. Iodine has -1. Sulfur has +6, and here we have -2 for oxygen. Don't forget that this 2 minus is not for the oxygen alone, it is for the radical. Next, we have to write out the half cell equation. For the half cell, we have IO3 minus becoming I minus, and then we have SO32 minus becoming SO42 minus. We have iodine having +5 as its oxidation number at the reactant side, but over here it has become -1. It means that it has gained 6 electrons, gained 5 and gained another one, so making it has gained 6 electrons. And so when it gains like that, that means it has undergone reduction reaction. And then we have sulfur, which was +4 here, and now it has become +6, meaning that sulfur has lost 2 electrons. And when it loses 2 electrons, it becomes +6. And so this is oxidation. Alright, so we'll take the oxidation reaction first. That is, we want to balance the atoms and the ions. So we have SO32 minus, which gives SO42 minus. We have 3 atoms of oxygen here, and we have 4 atoms of oxygen here. And so because of that, we have 4 here and we have 3. So we introduce 1 molecule of water, H2O. Now we are dealing with an alkaline medium. So because we have 2 hydrogen on this side, it will lead to the introduction of 2 OH minus. And because we introduce 2 OH minus here, we introduce 2 molecules of water on this side. Next, we need to balance the ions. We have 2 minus here, and we have minus here, then we have 2, that's 2 minus 2 minus, that's -4. And for this, we have just 2 minus on the product side. So to balance it up, what we need to do is that we would add 2 electrons on this side. So when we add 2 electrons here, that will balance the oxidation equation. Then we move on to the reduction equation, where we have IO3 minus, which gives I minus. From here, we have 3 atoms of oxygen here, and we have none here. So that will lead to the introduction of 3 molecules of water. So because we have 3 molecules of hydrogen of water here, now look at this. We have 3 times 2, that's 6 atoms of. So because of that, we have 6 OH minus over here. And then because we have 6 OH minus, we'll introduce 6 molecules of water on this side. Next, we need to balance the ions. We have -1 as the ion here, and we have minus and then 6 minus. That's 6 minus and -1, that is -7. So to balance it out, what we need to do is to add 6 electrons to this side. But we'll not add it there because we want the electrons to be on the reactant side of the 2 equations. that is of the oxidation equation and the reduction equation. And so instead of having plus 6e there, we have it as minus 6e over here. Next, we are going to multiply the equation 1 with 6 and equation 2 with 2, because we have 2 electrons and we have 6 electrons. So the 6 comes here and then the 2 comes here. And so we have 6SO3 2 minus plus 6H2O plus 12OH minus 12E minus, and then we have 6SO4 2 minus, and then plus 12H2O. Then we have 2iO3 minus plus 2 times 6, that's 12H2O minus 12E minus, to give 2i minus plus 6H2O plus 12OH minus. Next, the electrons will cancel out. Okay, over here we have a plus. So the electrons will cancel out because they have plus 12 minus 12. And next, we'll look at our water molecules. We have 6 molecules of water here, we have 12 over here. So when this comes over here, it will become 12 minus 12. So we have a resultant of 6 molecules of water. So let us write the equations without having the water and the OH minus. So first we'll have 6SO3 2 minus plus iO3 minus, and then so we have written this, and then we have written this, and then we have 6SO4 2 minus plus 2i minus. So we have this out and we have this out. Next, we are left with the hydrogen. 6 plus 12 here gives 18H2O, right? And then we have 12 plus 6 here gives 18H2O, meaning that the water molecule will cancel out. Then we have 12OH minus here, and we have 12OH minus here, meaning that the OH minus also will cancel out. And when they cancel out, this is what we are going to have. And so we could say that this is our resultant equation. Or if we take a close look at it, we have 2 over here. And so if you look at this, we have 6 water molecules plus 12 water molecules. That gives us 18 water molecules. And then we have 12 OH here. Alright. And then here we have 12 water molecules plus 6. That's 18 water molecules. And then we have OH, 12 OH minus. So the 18 water molecules cancels 18 water molecules, and 12 OH cancels 12 OH. So we could say that here's our net equation. But if we look at the equation, we have a common factor, which is 2. So when we divide through by 2, we'll have 3SO3 2 minus plus iO3 minus, and then 3SO4 2 minus plus I minus. So that is our resultant equation. Now I want to balance a redox equation using the oxidation number method. And we shall be balancing this particular equation. Now there are some steps which needs to be considered in this oxidation number method. Number 1, we have to write down the oxidation number of each element or ion present in the medium. And number 2, we have to determine the total number of electrons gained and the total number of electrons lost by each compound or ion in the reaction. And the step 3 is to balance the atoms present except the oxygen and hydrogen first, and then the electrons transferred. And then the 4th step is to balance the oxygen atoms by adding water molecules to the right hand side equation. And the 5th is to balance the hydrogen atoms by adding hydrogen ion to the left hand side of the equation in the acid medium. Similarly for the alkaline medium and hydroxyl ion OH. So let's proceed by balancing this equation using the oxidation number method. First, we write the oxidation number of each of the elements. Manganese here has an oxidation number of +7, oxygen here has -2, bromine has -1, and manganese has +2, and then 0 for bromine. Now from all this, it means that manganese has reduced from +7 to +2. It means that it has gained electrons. And how many electrons did it gain? It gained 5 electrons. So let's have that on one side. Then we have our bromine, which was -1 becoming 0, meaning that from -1 to 0 it has lost 1 electron. Alright, so we have that as 1 electron which was lost, and then here we have a gain. So the total number of electrons gained by each MnO4 minus is 5e. Now the next thing is that we need to balance the equation. How do we balance it? We have MnO4, which gives us Mn2+. We have one manganese here and we have one manganese. That is balanced. We're not introducing hydrogen or oxygen there. And then we have our bromine, that is Br- becoming Br2. So to balance this, we introduce a 2 over here. So that has balanced the atoms. The electrons now are balanced by multiplying the equation by the number of electrons. If you look at it closely, here we said that we have just 1 electron that was lost by bromine. But now that we have 2 bromine here, that means it has 2 electrons which it lost. And so the next step is to multiply each by the electron lost. We are going to juxtapose it. Now what we do now is to juxtapose the electrons that were lost or gained. Manganese over here gained 5 electrons. So multiply the 5 with this, and then this has lost 2 electrons. We used that 2 to multiply this. So we do that, we'll have 2 MnO4 and then 2 Mn2+. That's for the first equation. And then for the second, we have 5 times 2, that's 10 Br minus, and then 5 Br2. Now the next thing is that we'll combine the 2 equations. When we combine it, we have 2 MnO4 on the reactant side, and then on the reactant side we have plus 10 Br minus. Then on the product side we have 2 Mn2+ plus 5 Br2. Now we need to introduce our water and then hydrogen ion. To do that, we have 2 times 4, 8. That's 8 atoms of oxygen over here. But on this side, we do not have any oxygen. So we introduce oxygen here by bringing in water. That's plus H2O. Now since we have 2 times 4, 8. So we have 8 molecules over there. And that has introduced hydrogen. So the resultant will be to introduce 2 times 8, 16 H plus on the reactant side. So from what we have here, the equation is balanced. So we have balanced it by using the oxidation number method. Now we have to balance the redox equation using the oxidation number method. Now for us to balance this equation, we need to first write the oxidation number of each of the elements. Manganese over here has +7 and oxygen has -2. Iron over here has +2. Manganese has +2. Iron here has +3. So we have to note that manganese has decreased from +7 to +2. That means that it gained 5 electrons. So we'll have that somewhere. 5 electrons were gained. Alright. Then we have iron, which was +2 and it has increased to +3. That means that it has lost an electron. And so we have it as 1 electron which was lost. Is to balance the atoms of the elements. So we have MnO4 minus then Mn2 plus, and then we have Fe2 plus giving us Fe3 plus. When we take a good look at it, the atoms are balanced except O4, which we will balance later on. The next step is to balance the electrons. From here, we said that there's a gain of 5 electrons here. And so what we'll do, 5 electrons was gained by manganese. So we multiply this by 5. And here, and then iron lost an electron. So multiply this place by 1. And the resultant will be MnO4 minus Mn2 plus. And then 5 times this, that's 5 Fe2 plus, and then 5 Fe3 plus. Now the next is to introduce water molecules to the right hand side. Now that will be done by, we bring this equation together. This is the reactant, so we have MnO4 minus plus 5 Fe2 plus, and then we have, on the product side, we have Mn2 plus plus 5 Fe3 plus. We have 4 atoms of oxygen here, but we do not have here. So we introduce the 4 atoms of oxygen by adding 4 molecules of water. And because 4 molecules of water has been introduced over here, making us to have 2 atoms of hydrogen. So we have 2 times 4, that's 8. So we have plus 8H plus over here. And so we have this as aqueous, we have aqueous, we have aqueous, 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 and we have liquid over here. And so here is the balanced equation using the oxidation number method.